Reverse engineering and factoring lesson number 14. How strange is this? Follow and hang with me here, and you'll begin to understand where it is that I am going with this. What really happened at Roswell? For those of you who don't know, I don't know, right around the year 1950 or 51 or something like that, supposedly a UFO landed at Roswell, and there's a bunch of conspiracy theories, and we're not going to talk about whether UFOs are real. Personally, I think a UFO is real, but just an unidentified flying objects. Whether or not there are aliens, that's way above my pay grade, and I have no idea. I think most of these unidentified flying objects are military trial and experiments. But the rumor that a lot of people think is that supposedly a UFO crashed at Roswell, and that the government got a hold of it, and they did what we call reverse engineering. And this is the best example of reverse engineering that exists in rumor form. Supposedly, the government got a hold of this alien craft, and once they saw the solution, they went backwards to figure out how to get such technology into our hands. And for what it's worth, one of the things that the proponents of Roswell point to is the fact that right after that, our technological capabilities exploded. So who knows if it's true or not? I have no idea. But the concept of reverse engineering is very well fits the story of what went on at Roswell. True or not, I do not know. But before we actually do a lesson on reverse engineering, I do want to take a step back because as I record this video, I just got your test results. As a whole, they were excellent. The average grade on the test was an A. So clearly you guys did a really good job. But that said, we weren't perfect. And we need to, granted, we're never going to be perfect. I make mistakes. Definitely. And I used to make them all the time. So, and I still do. But given that we're not perfect, we're going to chase the heck out of perfection, and we're going to try to get there and try to do our best. I don't intend to make mistakes, but we do them. This is a singer which I think is pretty popular with the younger people named Drake, and he says, "I was born to make mistakes, not to fake perfection." Once I embraced the fact that I can make mistakes and I didn't have to be perfect, it took a lot of pressure off me. So it was a good moment. And you begin to realize a few different things about mistakes. For instance, some of the best lessons we ever learn, we learn from our mistakes and our failures. The error of the past is the wisdom and success of the future. I used to tell my students in class all the time that I knew what to do more than they did, not because I was smarter than them, but because I'd screwed up a bunch more in my life and I had learned things that they have yet to learn by the painful lessons of mistakes. So the error of the past is the wisdom and the success of the future. So if we apply that, there were 5 questions that were missed a little more frequently than other questions on the test. We're going to go over 3 of those questions today, and then we're going to go over 2 of those questions in our next lesson. And you can bet you're going to see them on quizzes again. You can bet you're going to see them on tests again. And I don't think you missed, I think you had the knowledge to get the questions right. I think what you missed is exactly what the questions wanted you to do. So without any further ado, let's go over those 3 questions. So this was the first one. Express in interval notation from -3 to 8, x bounded by -3 to 8. And what I really want you to notice here is the difference between the signs and what that implies in terms of bracket notation. The first one is that if you have a or equal to sign on the bottom, less than or equal to, it means you'll always use a bracket. And if you have just a less than sign like here, you will always use a parenthesis. So the correct solution to this one is choice C. Okay? Not like a whole, I think 3 kids in the class missed this question, but we want to make sure that we don't miss it after today. So here's one for you to do. Ready? Express in interval notation. Go ahead. What's the correct solution? It's not multiple choice, so just write out the answer. Okay, the correct solution would be, this time, the strictly less than is on the left, so the parenthesis has to go on the left. And the or equal to is on the right, so the bracket has to go on the right. Okay, so that was the first question that a few students missed on the last test. Here's the next one. Which interval notation best represents the graph? So clearly we had a little bit of an issue with interval notation. And in this case, an open circle is a way that we represent on the graph a parenthesis. And a closed circle is a way that we represent a bracket. So open circle, it means you're not allowed to equal it. It means that we can get closer and closer and closer to 3, but because we can never actually land on 3 because that circle's not filled in, you cannot equal 3. And a not equal situation, we just said, was parentheses. And then a closed circle means, yes, I can equal 7. I can get closer and closer and closer. As a matter of fact, I can go all the way up to and include 7 because that circle is filled in. Okay, so that means you can equal it, and an equal is represented by a bracket. Now, one thing that I really want to emphasize is it doesn't matter why you got this wrong. I honestly don't know if it's my fault for not teaching it as well as I could have, or your fault for maybe not learning it as thoroughly as you could have. It was one of the last topics that we learned, or maybe it's both. Whatever the case, it doesn't really matter. What matters is from this point forward, we get it correct, and you will see this again on a future test, multiple future tests, and on the final exam. Okay, so now next question. Go ahead, let's do stop and start on this. And there we go. This time the filled in part of it was circle was on the left, so that's the bracket, and the open part was on the right, so that's the parenthesis. Okay. Next, the length of a rectangle is 3 more than 4 times the width. If the perimeter of the rectangle is 86, find the area of the rectangle. And we hit these pretty hard. And I suspect that the problem wasn't so much with how to do the question as much as it is what the question was asking for. And I tried to emphasize this to you by putting that in bold. So let's check it out. Underline the important things. If the length of a rectangle is 3 more than 4 times the width, that's clearly very important. If perimeter is 86, that's clearly important. But then I triple underline this one and had it in bold because what they're looking for, remember Mr. Brace, what are they asking for? They want the area of the rectangle. They don't want to know what W is. They want to know the area of the rectangle. So now let's solve it. I draw my rectangle because we always want to draw a figure whenever we do a geometry application of algebra. The width is W, and it says that the length is 3 more than 4 times the width. Remember, more than, less than, last shall be first, first shall be last, and I get 4W plus 3. All right, so the perimeter is 86, and perimeter means add up all the sides. So the first side on the left is W. The top is 4W plus 3. The right is W, because remember they're equal, and the bottom, which is equal to the top, has to also be 4W plus 3. That's going to be 86. As you look at this, this is a same side, same operation situation. 10W plus 6 is 86. Subtract 6 from both sides, I get 10W is 80. Dividing by 10, I get W is 8. But we're not done, and this is where I think the mistakes were made on the test. I think, and you know that I put that 8 up there on purpose to see if you would bite. I think a lot of kids who got it wrong, and I think there are only 3 or so, maybe 4 kids who got this wrong. I think they saw the 8 and they bit, and they jumped at it. But the question said, what's the area of the rectangle? You always have to say, what are they asking for here? What do they want from me? They don't want 8, they want the area. So I have to carry that a step further. The way I carry that a step further is I say, okay, how do I find area? Well, area is length times the width. So we said the width is 8. I got to find the length, which is 4 times 8, which is 32, plus 3, which is 35. So I get 35 times 8, and that is 280. So the correct answer to this question is 280. Okay? All right. So now let's have you try this particular question. Go ahead. Remember, stop and start. Okay. So let's underline the important stuff. Length of a rectangle is 3 less than 4 times the width. Perimeter is 84. Clearly, that's important. Finding the area find the area of the rectangle is what they're looking for. I should have triple underlined that. I can't believe I didn't, but you should on your paper. This time it's 3 less than 4 times the width. Less than is minus. So when I draw my rectangle, the width is W and the length is 4W minus 3. Then I set them up into my equation, which says the left, which is W, the top, 4W minus 3, plus the right, which is W, plus the bottom, which is 4W minus 3. Has to all add up to 84. Same side, same operation. 1 and 4 W's make 5 W's, another one is 6 W's, another 4 make 10 W's. 3 negatives, 3 more negatives is negative 6 equals 84. Add 6 to both sides. I know I didn't show the step, but I'm confident you guys can do this. We talked about it before. 84 and 6 is 90. Divide by 10 and I get W is 9. But we are not done. Everything up to there is kind of business as usual, and we get into a very mechanical, not thinking about what we're doing kind of way of doing things. And so often, once we solve an equation and we get an answer of 9, we think, okay, we're all done. Move on. Let's get to the next one. But the truth of the matter is we are not done because it wants us to, as it says specifically here, find the area. So if the width is 9, the length is 4 times 9, which is 36, minus 3 is 33. To find the area, it's length times width, so it's going to be 33 times 9, which is 297. So that's a review of questions that gave you some difficulty on your test. I think for the most part, it can be cleaned up just by knowing what kind of mistakes we made. I don't think we made major mistakes. I think little finishing touches like read what the question asked for the area.